Hi folks, thanks for tuning into our session today. I'm Brandon Wu, and I help financial services institutions tackle their security challenges by building and operating securely in the cloud. I'm excited to be here today to speak to you all about some foundational best practices for protecting yourselves against ransomware on AWS. While I'll be using some specific examples and highlighting AWS services, the practices I'm going to cover today are truly foundational and can be applied broadly to any cloud environment. Services, of course, may vary. My goal today is really to provide some prescriptive guidance for you to get started and think about building those defenses against ransomware. So what are we going to cover today? We'll start out with a quick review of what ransomware is, just to make sure that we have a good understanding and baseline understanding. Dive into those foundational best practices for ransomware protection, and then I'll provide you some additional resources that you can use to learn more. I'll close out this session today with a quick demo of one of the practices in particular using AWS Security Hub, a cloud security posture management service that automates best practice checks, aggregates alerts, and supports automated remediation. So let's get started. What is ransomware? Well, ransomware refers to a business model and a wide range of associated technologies that unauthorized users use to extort money from entities. Unauthorized users use system vulnerabilities or social engineering tactics to access data, and then they restrict the rightful owner from accessing it. This is accomplished by a bad actor who encrypts data using actor-controlled encryption keys, using access controls to lock out the rightful owner from a system, or threatening to just reveal data through data exfiltration, which can result in large monetary fines from data privacy authorities, litigation from affected parties, among other potential consequences. And despite the spike in ransomware type events in the recent years, ransomware has actually been around for quite a long time. One of the earliest recorded instances dates back to the late 80s with the AIDS Trojan, where a floppy disk was left in a parking lot at a conference, and when inserted into a user's computer, the Trojan would run that demanded victims mail $189 to a P.O. box in Panama. It's believed that about 20,000 computer enthusiasts, medical research institutions, and researchers who attended the WHO's International AIDS Conference in Stockholm that year received these disks. Now, fast forward, in the first years of the 2010s, ransomware was profitable, but it wasn't very common. Cyber criminals actually had a very difficult time getting money from victims without using the traditional channels, the banking and channels that are available. And this underground industry blossomed, really, when Bitcoin emerged. In 2013, the world met the destructive CryptoLocker, the malware that kicked off the ransomware revolution. Let's walk through context for why ransomware is still very effective. Now first, the value of data on the open market is relatively low compared to the value of that data to the data owner. Although there's potentially major fines levied by privacy authorities for any sorts of breaches or disclosures of that data, that really provides an additional financial incentive for complying with bad actors' demands. And beyond that, there are two primary drivers to the pervasiveness of ransomware today. First, cryptocurrency valuation and access is easier than ever, which means that the business model for criminals is quite lucrative. Criminals now have an easy way to monetize and collect payments from victims. Second, the security environment in many organizations lends itself to the spread of ransomware. Many organizations have open trust models within the organization's network that allows for the spread of malware. And these organizations are often challenged with trying to balance the minimization of privilege with the ability to develop and move quickly. We also hear that many organizations report low levels of security awareness amongst their employees, and this is why we think we see phishing as a primary vector for both on-prem and cloud infections here. Many organizations are also really not backing up data, and even more are not testing the restoration processes for that data that is backed up. Next, we see overly permissive access and weak controls around privileged access management within many organizations today. And finally, Security staff at these organizations are typically overburdened by many manual processes. There's a low level of automation available in traditional environments, forcing these individuals and these team members to really work on things manually, slowing down their defensive practices. During the pandemic, we've seen a rise of cryptocurrency valuations and the working from home nature of the business, which has actually led to an increased market traction for cybercriminals as well, carrying out these ransomware attacks. Now, nothing I said today about ransomware is specific to the cloud. If anything, the cloud should be empowering your teams to really see your logging and monitoring, trim permissions, do security as code, really seeing your security practices improve. So these are all common reasons why ransomware is pervasive today. But what can we do about this? I always recommend to customers that I work with to baseline their security practices against a common framework. Many of our customers use a cybersecurity framework to map their security program and controls. And the most common security framework we see in the US is the NIST Cybersecurity Framework, the CSF. But realistically, any common industry adopted framework will work here. This will ensure that you have a well-rounded security program that's grounded in best practices. For our discussion today, we'll be focusing and aligning ourselves with the NIST CSF, but primarily in the first 4 domains here, the first 4 functions, which are focused on the protection or preventative measures that we can have. So we'll focus on identify, protect, detect, and respond. There are a number of other practices focused on the recover function as well, but we're not going to cover those today for time reasons. Now, I mentioned earlier that operating in the cloud and in AWS could really enable you to defend yourselves against ransomware much better than you could with on-premises environments. And why is that? Well, first, there are many AWS services and features that really help you protect against ransomware. We have one of the broadest ecosystems for security partner products, such as CrowdStrike, Falcon, and Trend Micro Deep Security, to really help protect your virtual instances, your server instances. Next, many of our customers are utilizing GuardDuty for detecting threats or anomalous activity within their environments, and utilizing services like Security Hub to automate those security checks and centralize security alerts. And when they're performing their investigations, they're using Amazon Detective to investigate those GuardDuty and Security Hub findings and identify the root causes of issues and events much more quickly. Next, many of our customers are using managed services that don't require traditional security practices as much, such as patching. So they're using services like Amazon API Gateway or AWS Lambda or Amazon DynamoDB. These are all serverless technologies. These are all managed services by AWS. So we handle all of that patching and undifferentiated heavy lifting for security activities for the underlying infrastructure for you. So you no longer have to do that. You can focus your resources on higher value add activities. Additionally, these managed services like DynamoDB, that massively scalable key value store database, or Amazon Aurora, these have point-in-time recovery features and capabilities that are available to you. Additionally, if you're leveraging services like Amazon S3, which is our simple object storage service, we offer features like S3 Object Lock, which uses worm protections, or write once, read many capabilities for objects that are stored in S3. And Object Lock can really help prevent objects from being deleted or overwritten for a fixed amount of time or even indefinitely. This really allows you to protect those specific files and objects you're storing there and prevent it from being impacted by ransomware events. And finally, Glacier Vault Lock and Vault Access policies really allow you to implement time-based data retention rules, and also the ability to deny the ability to delete those archives, and grant read access to designated parties, right? Another type of mitigation and protection against ransomware. And finally, you can really build for the cloud by embracing immutable and ephemeral architectures. Some examples of this include building security checks right into your deployment pipelines using CloudFormation Guard, an open source solution that we offer to check your templates for insecure configurations. or just using AWS CloudFormation to define and build your infrastructure as code so you can easily audit and redeploy it as necessary. And finally, you could use and build immutable infrastructure with no human access using tools like AMI Builder, AWS Autoscaling Groups, and Amazon CloudWatch Logs to ensure that the configuration doesn't change after deployment. And then you can redeploy it if changes are needed. So let's dive into some of these best practices for ransomware protection on AWS now. This isn't an exhaustive list, but it's a great start to ensure that you have a solid security foundation in place to build upon and mature upon. Through the rest of our session, I'll walk you through each chapter here to help you understand each item in this list and what AWS features and services can help you achieve these. So the first practice here is really patch and harden systems, right? It's a fundamental security practice here. In order to secure your systems, you need to be able to identify vulnerabilities in your environment. And we have several services that can help you identify those vulnerabilities. Amazon Inspector can help you search your AWS environment and virtual instances for common vulnerabilities, exposures, CVEs, and assess your instances against security benchmarks and fully automate notifying security or IT engineers when findings are present. You can also leverage Amazon ECR image scanning to help identify software vulnerabilities in container images. This service uses the database from the open source Claire project, which provides a list of scan findings for you. Next, once you identify issues, you can use AWS Systems Manager Patch Manager to deploy operating system and software patches to those instances. Systems Manager can actually run on your on-premises data center hosts as well as your hosts within AWS. Additionally, if you want to harden the operating system, which is really about configuring your operating system securely and updating it and creating rules and policies to really help govern the system in a secure manner. You can do this by minimizing a computer operating system's exposures to threats and mitigate possible risk by utilizing CIS pre-hardened images, which are available on the AWS Marketplace as well. And finally, you also want to make sure that those instances you're deploying may be running some sort of endpoint protection software if necessary. So you can leverage solutions like CrowdStrike's Falcon or Trend Micro's Deep Security, as I mentioned earlier, that are also available on the AWS Marketplace for purchase. Keep in mind, though, that you really want software to be in this kind of protect mode, so it can prevent malware and ransomware attacks as opposed to just detection mode, so that you can see things and respond to them. The next practice is really striving towards that least privilege goal. And this really means eliminating or minimizing the use of things like static access keys, right? This is a really top security risk that we've seen within customer environments, and leveraging these static credentials opens you up to accidental leakages and causes security events for our customers. Please only use these static keys if absolutely necessary and if you have no better option. You can also apply multi-factor authentication and reduce the permissions if you do use them. The next practice that we see in terms of least privilege is really federating access using some sort of least privilege policies. You can leverage services like AWS SSO single sign-on to do this and grant access to your AWS accounts. And the latest version of the command line interface provides federated users the ability to obtain temporary access keys, so those static credentials are no longer needed. Next, once you have permissions and roles defined, you could leverage service last access capabilities within AWS to run Access Analyzer on access policies to determine if any services or actions haven't been used and can be removed. This enables you to continuously tune your policies and permissions over time. And finally, we always recommend to our customers to enable service control policies, these SCPs, at the organization level. And this is a really great way to reduce what AWS services and regions, for example, can be used, as well as ensuring certain critical services can't be disabled, such as GuardDuty and CloudTrail. These provide those overarching guardrails that your AWS accounts must operate within. The next practice is leveraging multi-account structures and strategies and network segmentation to really limit the scope of impact of any sort of security event. Consider that an AWS account is really the key security boundary. It's a natural isolation boundary for all of your resources within that account and within AWS. It's the ultimate lateral movement restriction here. And based on your own security requirements, I tend to lean towards mapping critical workloads to their own AWS accounts to provide the highest level of isolation and segmentation. In addition, you might want to have a common VPC, a virtual private cloud design across your accounts that enables developers to build systems securely, ensuring that they don't deploy instances in public subnets, but utilize load balancers for that to reduce surface and exposure to points to the internet. We recently released the AWS Security Reference Architecture, which is a best practice guide to help you design these AWS security services in this multi-account environment. It also includes a repository for AWS CloudFormation templates to help your developers and engineers deploy these AWS services in this multi-account environment as well, following the pattern and architecture. The next practice is really developing and exercising your incident response plan. You must always plan for failure. The first important point I want to make here is setting up your incident response plan now, before you have an incident. Build out those runbooks, test them, and make sure that they're operating the way that you expect before you experience an actual security issue. I'd recommend building your runbooks and then running them at least in a tabletop exercise fashion, just to walk through them and make sure that all the steps are captured and all the dependencies are identified. Many preparation steps are needed to perform incident response, and doing them ahead of time really allows your organization to spend more time focusing on measures to improve the security of their cloud environment and applications. Some of these preparation steps might include preparing access to your AWS accounts during the times of an incident, so maybe additional considerations that may be necessary for levels of access beyond what is typical to perform those types of investigations by a central team. Maybe you want to also prepare and think about the types of remediations that you're comfortable making and what additional context is necessary to take the right types of actions. For example, you might want to pull tags in from your resources, as the action you take may be different for systems tagged with a dev tag versus a production tag, for example. Another key preparation step is having a forensic environment or workstation built out in advance, or having the ability to automatically provision those forensic tools as you need them. Where do you want that system to live? And can you build it ahead of time or have automation in place so that you can deploy it when you actually need it in a very quick fashion? And have those systems in a shutdown state so that you're not charged for them when they're in use, but you can spin them up quickly. The next important point, and my personal favorite, is actually something you should do after your runbooks have been built out and testing them, and that is really to start building in auto remediation actions to automatically resolve security misconfigurations. This is a huge cloud differentiator, and it's really fun to work on this area because it's really what makes security engineering in the cloud so great. Back in the on-prem days, we just didn't really have the same amount of tools and APIs to work with, but in the cloud we do, and we can enable this automated remediation capability. There's many solutions for setting those security guardrails and automatically remediating security response in AWS. You could leverage AWS Managed Services like AWS Config or Security Hub to identify those non-conformance to security controls and your cloud security posture. AWS Config provides those remediation options for config rules directly in the console using Systems Manager automation documents or SNS notifications so that you can automatically remediate any nonconformance identified. In addition, late last year, Security Hub released a set of CloudFormation templates and an implementation guide that provides predefined response and remediation actions that you can use as well against the CIS standard checks. Or you also have the option to really build your own custom auto remediations as well using a remediation framework, and several standalone AWS services can be put together to do this. Security Hub is a great source for taking auto remediation steps, given it's really our central hub for security findings, and it also sends all of those findings automatically to an eventing bridge, our CloudWatch events or event bridge service. You can create a CloudWatch or event bridge rule here for a specific type of finding, such as maybe a high severity guard duty finding on an EC2 instance, and call out to Lambda's function to kick it off, or a systems manager automation document to take action on that host. Maybe you want to take some containment actions on the host to apply an isolation security group or firewall rule to that instance. Maybe you want to pull some host-based logs off of that instance for forensics and automate that forensic log and artifact capture process. In addition, you can also send notifications to your security operations teams via an SNS notification to maybe PagerDuty or Slack notifications, or whatever type of notification service you're using internally. And finally, I highly recommend that all of the customers that I work with perform self-assessments regularly. There are several mechanisms available today to help you assess your AWS environments and workloads against best practices. First, you can use the AWS well-architected reviews as a mechanism to assess your AWS workloads for production preparedness. The well-architected framework covers a whole slew of AWS best practices that we've gleaned from working with our customers and internal stakeholders to define what it means to be building a well-architected application or workload on AWS. And I highly encourage customers to establish an ongoing mechanism using the well-architected review to assess your workloads on a regular cadence as part of your SDLC. At a minimum, you should be performing the well-architected reviews prior to going to production, and then at some point after the workload is moved to production to make sure that all of the gaps have been mitigated. Next, there's a number of security standards available for you in Security Hub, which I'll show you during the demo portion in a little bit. But you should be really running some of these security standard checks, like the AWS Foundational Security Best Practices standard in Security Hub. This will continuously assess your environments against the security best practices that AWS provides. And these best practices were really built by AWS security experts who maintain and update these checks on a regular basis as the platform continues to evolve. So you don't have to build and maintain your own custom checks. Our goal here is to really enable you to have opinionated guidance on security configurations across all of our AWS services over time. So by using the AWS Foundational Best Practices, you can assess your AWS environments for security configuration best practices. You'll notice that we have continuous releases for additional checks within the Security Hub service, as this is an area we're continuously investing in. The next item I'd highlight here is really this open source solution that our AWS service teams have put together. It's our AWS Security Assessment solution. And it has a module built in for ransomware specific checks as part of this service as well. It's available for you to review on GitHub, but it leverages open source solutions like Prowler and Scout Suite to do the basic configuration assessments, and then also includes these custom modules that will check for ransomware specific findings. And finally, in addition to AWS specific services and open source options, there are a number of third-party tools that provide these self-service security assessments as well, such as Palo Alto's Prisma Cloud or Cloud Health. And these are great options for customers as well if they're looking for a more commercial option. Thanks for tuning in. Those are all of the best practices that I have for all of you, but I wanted to leave you with a number of resources that you can leverage to learn more. And you can take a look at these after the session, but there's a number of best practices here that you can read up upon to help improve your security posture on AWS. Finally, if you needed some additional assistance here, AWS also has a professional services offering that can perform a number of security assessment and assistance services for you. And I'd highly recommend you reaching out to an account manager if you're interested in exploring any of these options. With that, thank you all for your time, and it's been a pleasure speaking with you. I'll pivot over to our demo portion just to show you how you can leverage AWS Security Hub to get that continuous posture assessment for your security configurations within your AWS environment. All right, so this is my Amazon Web Services console, and I've created a sandbox account here for the purposes of this demonstration. Within this account, I've enabled a number of security services already, such as AWS Security Hub, AWS Config, and Amazon Guard Duty. And I've also deployed a number of other third-party services within the Sandbox account to generate additional security findings. So during this demonstration, we'll take a high-level look at the features of Security Hub. AWS Security Hub is a cloud security posture management service that performs security best practice checks, aggregates alerts, and enables automated remediation. Security Hub really enables your security teams to automate security checks and centralize security alerts across your AWS environment. So the first thing we'll do is that we will hop over to the Security Hub service. To do this, we will just do a quick search here for Security Hub and select the service from the list. Now, when you visit the service after it's been enabled, you'll be brought to the summary page that provides an overview of security and compliance across your AWS account. From here, you can see the pass-failed status of security standards that you have enabled with an overall security score. I just enabled the AWS Foundational Best Practices standard a short while ago, and you can see that it's already starting to populate a partial list of results for the standard for the checks that have been performed. Now, as you scroll down this page, you can also see a number of graphs under Insights. If you hover over your mouse over one of these graphs, you can see a breakdown of the data. For example, this graph shows the new findings over time for the various findings providers and breaks them down by the source of the findings that have been aggregated into Security Hub today. Now, another example of an insight is the accounts with the most findings by resource type. You can see here that this will show you a breakdown of the findings by resource that's deployed within the AWS accounts, grouped by the AWS account that it belongs in. If this instance of Security Hub were managing the organizational deployment, you would actually see a bar here for each of the various AWS accounts within the environment, and you'd be able to drill into each of these in the same way. Now, that's just one side of the story. This is just a high-level view of the summaries, but AWS also offers a number of integrations to pull findings into the Security Hub dashboards. Security Hub provides the ability to integrate security findings from AWS services as well as third-party products. For AWS services, Security Hub automatically enables the integration, and you can optionally disable each integration. For third-party products, Security Hub gives you the ability to selectively enable the integrations and provides a link to the configuration instructions related to that third-party product. Now, Security Hub detects and consolidates only those security findings from the supported AWS and partner product integrations that are generated after Security Hub is enabled in your AWS accounts. So it's not going to go back and retroactively detect and consolidate security findings that were sent prior to enabling Security Hub. So to be able to view these integrations, you would just click here on the left-hand navigation pane on integrations, and you could see a list of the various service integrations as well as third-party products that are available to be integrated within Security Hub. So let's take, for example, if you are using the open source product Cloud Custodian, you could filter here for Cloud Custodian, and you could see the available integration for Cloud Custodian here. All you'd have to do to enable this is click on this Accept Findings button, and it will show you the IAM permission policy that's going to be required to be able to ingest the findings from Cloud Custodian into Security Hub. So from there, you just click Accept Findings, and that configuration will be enabled, and you will start receiving findings from the Cloud Custodian deployment that was already released into this account. Now, once you have all of these security findings from different services and different third-party services, you really want to be able to drill into what those findings are. So Security Hub imports findings from AWS Security Services and those third-party integrations that you enable, as well as other custom integrations that you might build. Security Hub will consume these findings using a standard findings format called the AWS Security Findings Format, which is ASFF for short. And this eliminates the need for time-consuming data conversion efforts. Security Hub then correlates the findings across the integrated products and helps you prioritize the most important ones. So to be able to drill into the findings, you would click on the findings on the left-hand navigation pane. And this is going to be the default view of the findings here. And there's a lot of information for you to consume. To narrow the overall list of findings down to some search criteria, you could just click on the search bar here, or this filter. And you could enter the field of severity label. So let's just scroll down here. And we could say we only want to be able to see the findings that are of medium severity, let's say, for example. Now this is going to apply that filter so that all of the findings that are displayed within this table here are going to be that medium severity level. Now if we just click on any one of these, the title here will bring you to the details of that finding to get more information in the details page. Now on the details page here, you can scroll down and be able to see the resources that are impacted by this finding. And if you click on the resource type here, you can see that this is an EC2 instance that's impacted. And if you click on this plus arrow, it'll actually add that to the findings filter search above. So now we are going to be filtering the findings by findings that are impacting EC2 instances. So let me just go back into the screen here. And you can see that these are all EC2 instance type findings here. Additionally, you could actually go back to the findings pane for an individual finding. And if you click on the actual findings ID here at the top, you can display the full JSON for what's pulled in from the actual findings data. This would be just a JSON format of all of the data elements that are going to be included in this one finding here. And you could actually download this as well for later on if you wanted to analyze this for further investigation or use it in another tool set. Now that's great. You can get a look at all of the individual findings within Security Hub. You can drill into the details and see the resources that are impacted. But a great feature of Security Hub is this concept of Security Hub Insights. And Security Hub Insights are a collection of related findings that are defined by an aggregation statement and optional filters. An insight identifies a security area that requires attention and intervention. And there's a number of managed or default insights that Security Hub offers out of the box. You can't modify or delete these, but you can also create custom insights to track security issues that might be unique to your AWS environment and usage. So if you take a look at the findings pane here, you can filter here for severity. And if you take a look at this, this will be the severity counts of your findings. And you can see here, you can see how many medium findings you have, high, low, information, and critical. And if you wanted to drill into that and see, show me all of the critical findings, you can click on that here, and you'll be brought to the findings page that is filtered on this critical severity level. Now that shows you how you actually work within Security Hub to see the different types of findings, be able to draw insights out of the data that's available to you. But how is it actually getting all of these security findings, and what types of security checks are also performed within your accounts? This is where security standards comes in. Security standards are a set of controls that Security Hub will automatically assess within your AWS accounts on your behalf. And we currently support 3 different security standards that are available within Security Hub. There's the AWS Foundational Security Best Practices, which is the standard set of controls that detect when your deployed accounts and resources really deviate from security best practices. These controls include best practices from across multiple AWS services, the most commonly used ones, and we've been adding additional services over time with the goal of really addressing all of the security settings and configurations for all of the services that are available within AWS. Now, each of these controls belongs to one of the following categories, which are based on the functions described in the NIST Cybersecurity Framework. These controls are curated and updated continuously by AWS experts, so you always have the most up-to-date recommendations from AWS by using this standard. Now, if we wanted to drill into this, we can actually take a look at the specific security findings for the best practices standard here. If you view on the results, you could see a breakdown of the failed checks by severity level, as well as an overall security score against this particular standard. And down on the bottom here, you can see the various types of checks that have been enabled, as well as the status of those checks for compliance purposes, whether they're passed or failed. So if we wanted to just pick one of these, let's say we took a look at the security groups should only allow unrestricted incoming traffic from unauthorized ports, from authorized ports. We could take a look at this finding and we could see a detailed view of what resources are affected by this finding. Now, this is a really great check to have, especially when you consider the ransomware topic of this conversation, because what you really want to be doing is really reducing the network paths inbound between your different resources and making sure that your security groups are appropriately filtering network traffic. So for this particular finding here, it's going to identify security groups that really allow unrestricted incoming traffic. So incoming traffic that is over anything other than port 80 and 443. Now, if you wanted to, you could actually scroll down and take a look at some of these findings as well, and you can click on the details here if you wanted to get a little bit more information on the actual data by going to this investigate here. If you click on the configuration timeline here, you can actually take a look at this particular resource within the AWS config service and see the configuration changes of this resource over time. So you can do further investigations of when this when this particular configuration fell out of compliance from the control that you have defined, as well as all of the previous configurations that were tracked within the config service. So you can see here that the rule compliance fell out of compliance looks like earlier today. Now, if you wanted to hop back into Security Hub, we could take a look at the usage information for your AWS accounts as well. And this helps you really understand what your monthly billing estimate will be for Security Hub and which components of Security Hub are contributing to your overall bill. Now, Security Hub offers a 30-day free trial for each account, so you can enable this and get this view of how much Security Hub might cost you over a course of a month or a year if you aggregate that out. During the free trial, Security Hub provides this estimate of what the spend would be, so you can assess that spend beyond that free trial period. So to see this information, you click on the settings on the left-hand page, and you click on usage here on the settings page. And on the left-hand side, you can see the usage for the billing period is being displayed. And usage is broken down by the findings ingested and by security checks that have been run. At the bottom of the usage summary is the total estimated cost for the billing period. So on the right-hand side, you can also see the current Security Hub pricing, so you can see how the usage in your account contributed to that overall cost. But you can see the estimated cost for this billing period is only really $4.43. So you can extrapolate that out to a longer period of time if you'd like to get an estimate for more total cost of ownership reasons. And that concludes our session for today. Thank you all for tuning in. I really appreciate you giving me the opportunity to talk to you about ransomware protections on AWS. Just to recap, we covered a quick overview or review of what ransomware is. We dove into some of those foundational best practices for ransomware protection and reviewed some additional resources that you can use to learn more. Then we took a quick look at AWS Security Hub to help implement our best practice recommendation of performing self-assessments against your AWS environments. Thanks again for your time and happy building.